Welcome to another 88K model railroad video. In this video we're going to look at the WIO demo board and the build process. This is the build process for the Raspberry Pi Pico W. Now if you look over to the far right, you can see we use the wire wrap method, and the wire wrap is more reliable when it comes to making the connections itself, and it's a lot cheaper and faster than building or having a PCB made. And it's it's beneficial, especially like if you're doing in-house work. Then you can pretty much get it done within, your project done within a day or so, versus having to wait a week for that whole build process for the PCBs. Now you can see that this board, or the connections, are more complex, and trying to do the solder tracing would just be a hassle itself. So before we go to the bench, let's look at the pinouts and the schematic for the WIO demo board. So let's look at the I/O pins for the Pi Pico W. Now the load that you install on the Pi Pico actually makes the assignments for the GPIO pins. Now the I/O pins, or the I/O ports, are assigned to the GPIO pins. Now I've got them noted in the blue, and then the GPIO pins are in the green. So you can see that there's two banks, IO 1 through 8, and then IO 9 through 16. And if you look at the GPIO pin, GPIO 10, and that's position 14 on the Pi Pico, you'll see 1 through 4, and that's assigned to GPIO pins 10 through 13. And then you see 5 and 6 is on 14 and 15. Then coming over to the right side, you see the IO 7 and 8 as it goes upward. The GPIOs is 16 and 17. Then on bank 2, you've got IO 9 through 12, which is assigned to GPIO 18 through 21. Then, and notice it skips the ground, so when you do the wiring, just make sure that you don't wire everything in sequence. So GPIO 22 has IO 13, IO 14 and 15 is connected to GP 26 and 27, and then the final IO 16 is connected to GPIO 3. Now you can look at the gray values show the pin position on the board. So whenever you do the wiring, make sure you create a little cheat sheet, and then also put little hash marks on the board itself, or on the back of the board, so you know exactly what pin is what. So because you don't want to get down and wire, half the board and then see that you're off a pin. So now let's look at the schematic. So with the schematic here, we see pretty much the same assignments. You see the GPIO, and this is just a schematic, so it's not positioned in the orientation of the board. This is just as the wiring reference. So you can see that GPIO 10 through 15 is 10 through 17 is supporting the bank 1, and then the 19 through the 26 and 27, and then up to 3 supports the second bank. Now to the left of the Darlington array, you can see these are 2-pin connectors, and there's 8 ports, and this represents the input ports to the Darlington transistor array. And now this is a signal lead that comes from the sensor. So the sensor has 3 leads: 2 input for the power and ground, and then its output is the signal lead, or what they call the S lead. Now that S lead comes in, let's say for example on the first port, it comes in, it activates the input on the Darlington transistor, and that with its adjacent when that 5 voltage comes in, that adjacent port is now switched to ground, and now the Pi Pico has 3 volts. And let's say, for example, we use the first I/O, that's GPIO 10. So GPIO 10 has 3 volts that's sitting there. When the voltage comes in on the left side from the signal, it causes that adjacent port to switch to ground. When it switches to ground, then the Raspberry Pi sees that, and then that's what causes it to send out the high state for that particular GPIO, and then the Rockwell will see that, and then that's how it knows if there's a particular event on that particular I/O port. This takes care of the schematic, so now let's go over to the bench and look at the parts. Here we are at the bench, and these are all of the components needed to build the demo board. Now to the right here we have the header pins. Now typically the header pins come in a 40 count on a strip, and in this project you need 2 of them. Here's 20 pins on the right side, 20 pins on the left side for the Pico, the Pi Pico. Then you have the Darlington breakout board, and it has 10 pins on each side. So now you can see the count. Here's 1, which is a total of 40, and then 4 10 groups of 10 pin, which equals 40. Now these are the perf boards that you mount the Darlington transistor array onto the board. Now these chip legs are the pitch, or the separation between the pins are almost at a millimeter, if not less, and there's no way you're going to get a soldering iron or be able to solder wires to it. So the breakout board becomes an easy way to mount them onto the perf board. Now these boards have what they call a pitch of 2.54 millimeters, and that's the same with the headers. So these will slide directly into those pins. And now you have also these are the 90-degree header pins, and they're 2 dual row ROW, and they're a total of 10. And now the 10 count supports this ribbon cable, which has 10 pins or 10 connections. Now you've got the you've got the 1 power connection. This is a DC input for the sensors, to power the sensors. Now this is the distribution board, and this board with the 8 connections is how you fan out all of the 8 ports from the Darlington transistor array. And now here are the 2 sensors, and these sensors are the KY18s, I believe, and these are the photo sensor or photoresistor sensors, and that's when the train runs over the sensor. Then this particular model, what it does is outputs 5 volts, and that's what triggers the Darlington array, or one of the ports, and that's how Rockwell knows that the sensor has been activated. So now this is the whole basis for the project itself, for the build project. And now let's look at the boards themselves, or the assembly and soldering process.